The question is to find the extreme values of the function and where they occur for the function g of x equals e to the negative x, and we're only interested in the interval from x equals -1 to x equals +1. It's a closed interval. X is allowed to equal those 2 points. All right, well, in order to find extreme values, the candidates for where extreme values can be found is at the end points of the interval and at critical points. Critical points are where the derivative of the function equals 0 or the derivative doesn't exist. So let's look for critical points here, which means we're interested in the derivative of our function. The derivative of e to the negative x is negative e to the negative x, and if you think of e to the negative x as a negative exponent, putting it in the bottom of a fraction, that's -1 over e to the x. So now we're interested in when that thing equals 0 and when it doesn't exist. Well, it's a fraction. The only time a fraction can equal 0 is if the top equals 0. But the top is 1 or -1 if you put the negative sign up there. Never equals 0. So there's no value of x that makes that fraction equal to 0. Great. Now let's think about when the derivative doesn't exist. Really, if you're looking at a fraction, the times that you're interested in for where it might not exist is when you're dividing by 0. So now we're thinking, when does e to the x equal 0? It never equals 0. It can approach 0, but it's never going to actually get there. So what we end up with is that g of x never equals 0, and it always exists for any value of x. Well, that's great, because now our candidates are pretty simple. Let's make a little table for our candidates here. We're going to look at the candidates, and we're going to evaluate the function g of x at those points. The only points we're interested in here are the end points, -1 and +1, because there were no critical points. G prime never equaled 0, and it always exists. So we only have to evaluate at the end points. That's why it was important that this was a closed interval. If it had been the open interval from -1 to 1, there wouldn't be end points. And so we wouldn't have any candidates. We would be done with the problem and say there are no maximum or minimum values. But we do have endpoints, so let's evaluate. At x equals -1, we get e to the -1, which is 1 over e, which is about 0.368. And when x equals 1, we get e to the 1, so that's just e. E is roughly 2.718. All right, once you've gone through the process of evaluating your function at all the candidate points, we're ready to answer the question. You look at the table and you find where the function takes its smallest value and where it takes its largest value, and you use those to answer your question. Those are your minimum and your maximum respectively. So we can say in the interval from -1 to +1, a closed interval, g of x has a minimum value of 1 over e at x equals -1 and a maximum value of e at x equals 1. And that's all there is.